Welcome to another Intermediate Algebra broadcast. It's me, Gary Parker. We're going to take a look at some rational expression stuff. So hopefully you've noticed I posted a couple of more quizzes related to Chapter 5, one on rational expressions, simplifying, and one on solving rational equations, which is about the end of Chapter 5, which you should be on right now. So quiz 5 is due this Friday. And it's on simplifying rational expressions. So we just have a simple one to reduce there, a multiplication to simplify, a subtraction to simplify, and what's called a complex fraction. Hopefully you've caught on that each of these quizzes are related to your final exam. So part of your final exam at the end is called an exit exam. And there is a practice exit exam online here and a couple of sample printed ones here and here. And then there's 7 parts to these exams, 4 questions for each of the 7 parts. That's 28 questions altogether. And here I break them down a little bit further. So for example, after you take the practice exit exam, you'll get feedback as to how well you did in each of the 7 areas. And so then what you can do is based on this here, you can say, well, this apparently is my weakest area. And you can go back to that section on the exit exam and review it. So rational equations maybe was your toughest part. And so this will bring up 4 questions at a time based on that topic, like you'll see on the exit exam. So these are just like the problems you're going to do in the quiz. Let's take a look. Get my magic pen to work. Come on, pen. There we go. So first we just want to simplify this. Now we can't just cancel this y here with that one down there because the addition sign stands in the way. If you consider the order of operations, before you can do the division, you have to clean up the numerator and you have to clean up the denominator. Since you don't know what y is, you can't do that, which means you can't divide, and canceling is division. So there's nothing I can do right away. In order to proceed on this, I have to be able to factor the numerator and or the denominator. So let's give it a try. The numerator, y plus 4, is as simple as it gets. But the denominator, you guys should be masters of stuff like this. My hope is you'll look at this and you'll guess that it factors as a pair of binomials, y times y. Now 20 could be a bunch of different options. So remember our routine, 1 times 20, 2 times 10, and 4 times 5. So we want a middle that adds, or middle, we want to be able to add or subtract to get the middle term here. In this case, that's a minus 20, so I want to subtract these, and 4 minus 5 gives me negative 1, which is in the middle. So that means the 4 has to be positive, and the 5 has to be negative. So that's the factored form of that denominator. And now I can see, since I've broken it down as to a multiplication, because division and multiplication are opposite operations, I basically have a number divided by itself. A number divided by itself is 1. So that means this expression is really equal to 1 over y minus 5. So that would be the simplified form, and circle it. I'd be expecting to see some work similar to this on your paper when you turn in your quiz. Let's try the next one. Next one here, we want to multiply and simplify. And on this one right here, I think we should factor that numerator. So I'm going to slide this down a little so I can factor in place. And the numerator, let's see, x plus 4, nothing I can do. X plus 3, nothing I can do. X minus 1, nothing. But up here, that will probably factor. And I'm going to guess that x times x to get x squared. 6 could be 1 times 6 or 2 times 3. Since everything is positive, I'm going to guess it's 2 times 3, because 2 plus 3 is 5 in the middle. Anytime you do factor by guessing like that, off to the side, you should multiply it out to make sure it gives you back what you think it does. I'm pretty sure I'm right there. Whenever you multiply, you get a bunch of stuff multiplied in the numerator and a bunch of stuff multiplied in the denominator. So that's my numerator. And my denominator would be x plus 3 times x minus 1. Now, everything in the top and bottom is connected by multiplication here and here. And so anytime you multiply by a number and then divide by that same number, why, you have a number divided by itself that is 1. And so cleaning this up, 1 times stuff in the top is the other stuff in the top. So I'm going to get an x plus 4 times an x plus 2 divided by x minus 1. And I wouldn't recommend multiplying this out because I can clearly see nothing else cancels. So this would be my answer. Let's try another. Subtraction's a little bit different. In order to subtract, you have to have a common denominator. In order to find a common denominator, each denominator has to be factored. Well, x is as simple as it gets, but x squared plus 5x, that factors. I can pull out a common x, leaving x plus 5 as the other factor. So that's my new denominator. And that, it turns out, is also going to be my lowest common denominator. So this one right here is missing a factor of x plus 5. So I have 7 over x, and I need to adjust it by multiplying it in an x plus 5, which I also have to do the same thing to the numerator. That right there, and then I'm going to have to subtract the 7 over x times x plus 5. As far as subtraction goes, as long as you have a common denominator, you keep it and subtract your numerators. One numerator is 7 times x plus 5, which I can say is 7x plus 35. The other numerator is minus and then 7. Here I can clean this up because 35 minus 7 reduces. And so I think the answer is 7x plus 28. All over x times x plus 5. Now, I still need to see if this reduces any further, so I need to try and factor the numerator. The denominator is already factored. We'll leave it that way. And here I notice there's a 7 common to each piece in the top. So if I pull out that 7, I get x plus 4 as the other factor. And neither of those factors is like either of the factors in the bottom, so this doesn't reduce. And I would say this would be the final answer. Now, just a note on typing that into the computer, because that can be a little bit tricky. Let's find that one. That was question number 3 here. And you can't really blow it up too much more than that. Anytime you have something complicated, I highly recommend using the equation editor. So I can say I have a fraction. The numerator of the fraction is 7 times x plus 4. And then click down below. The denominator of the fraction is x times x plus 5. The multiplication in this case is optional. The computer recognizes no symbol as times, but I like putting in there to be clear. Save it. And then it will rewrite it so that it's formed correctly. So it puts extra parentheses where you need it so that it comes out right. It says syntax is OK. That looks like what I had in my paper. So then I'm going to submit it. And I got it right. OK, let's try the next one. And you'll notice these are similar to, oops, wrong button, to the questions on your quiz. So here I have to simplify a complex fraction. So I have an addition with a fraction, divide, and subtraction with a fraction. A couple of ways to deal with this. One is to just follow the order of operations. I'll show you both ways. And realize that before you can deal with this division right here, you have to carry out the addition and this subtraction down there. So in order to take 2 and add 1 over x, I need to have a common denominator. So I'm going to view that as 2 over 1. plus 1 over x. Denominator here should just be x. So I'm just going to multiply by x, top and bottom. So that gives me a common denominator of x in the top, and then my numerators are 2x plus 1. Okay. So I now have a new numerator because I dealt with that addition. I have to deal with this subtraction. So I have to rewrite that as x over 1 minus 1 over 5. Common denominator would be 5. So I'm going to have to multiply by 5, top and bottom here. So that's going to give me a common denominator of 5 in the bottom. And then I have 5x minus 1. So now to deal with this fraction bar right here, recall that division with fractions is multiplying by the reciprocal. So we take our first fraction, 2x plus 1 over x, and we're going to multiply by the reciprocal of the denominator fraction. In this case, all I can really do is multiply across the top and multiply across the bottom. And so it looks like the answer is, I'm going to write it as 5 times 2x plus 1, which you could distribute if you want, over x times 5x minus 1. The reason I leave it undistributed is I can see that there's no common factor of 5 on the bottom. There's no common factor of x on the top. 2x plus 1 is very different from 5x minus 1, so nothing cancels. That's my answer. Alternative way to attack this would be to find the common denominator of the top and the bottom. So find an LCD for everything. And if you read the book and watch the other videos for this section, you'll see that this is the other technique. So here I have a denominator of x, here I have a denominator of 5, so the common denominator is 5x. So then what we do is we multiply both the numerator by 5x and the denominator by 5x, which is a legal thing to do with fractions, because 5x divided by 5x is 1, so I'm technically not hurting this. Now the cool thing is when I distribute that through, I'm going to get a 5x times 2, which would be a 10x. And then I'm going to get plus 1 over x times 5x. And the cool thing about that is I just designed this so that the x's divide out. They cancel. In the denominator, I'm going to distribute. And that's going to give me 5x times x, which is 5x squared. And 1 minus 1/5 times 5x. And again, this is set up so that this 5 down here cancels with that 5 down right there. So let's clean up and see what we have left. In the numerator, I have a 10x. 1 times 5 is all that's left, so I have a 10x plus 5. In the denominator, I have a 5x squared minus 1 times x, or just x. So I think that's the answer right there. To be sure it's reduced, I should factor the numerator and denominator. So notice that 10x plus 5 has a common factor of 5, which leaves behind a 2x plus 1. And the denominator, we have a common factor of x, which leaves behind a factor of 5x minus 1, which exactly matches what we ended up here. So 2 different techniques. One is just follow the order of operations. Clean up the numerator, clean up the denominator, view division of fractions as multiplying by the reciprocal. Clean it up. The other, find the LCD of the top and the bottom combined, multiply the numerator by that LCD, multiply the denominator by the LCD, bunch of stuff cancels, see what's left. Either way works. Some people like one method better than the other. You got 2 to pick from. So I believe that's the answer. Since nothing reduced, either this version or that version is acceptable. Had I done it this way, I probably would have circled that as my answer. Over here, I circled that as my answer. They're both correct. They're both simplified. All right, so what should you be doing besides taking the quizzes I posted? Zoom out a little. So there's going to be one more quiz I'll post next week. That's kind of a review of some stuff we did earlier. For now, you want to get this rational expression quiz taken as soon as possible. That's due Friday the 8th or 9th? The 9th. And then this rational equation quiz is due by Monday the 12th. I would highly recommend this weekend you take the practice exit exam. See how you do. You'll get some feedback. That feedback after you take the exit exam will look something like this right here. Based on this breakdown, take the sections you did worse in and go to the exit exam in 7 parts and practice the parts that were the hardest for you. Maybe it was radical equations and rational equations. Maybe it was quadratic equations part 2. Maybe it was radical expressions. Whatever they are, practice it until you get better. Then go take the practice exit exam again. See how you do. On the practice exit exam, you got to get 21 out of 28 correct or better. Okay? Keep taking the practice exit exam until you can get every single problem right, so that when you take the real exit exam, you're going to at least get 21 out of 28 on your first try on the real one. The real one is just like the practice one, different set of numbers. So the more you take the practice exit exam, the more you'll be prepared for the first half of your final. The exit exam is pass-fail. You got to get at least 21 out of 28 or better to keep your passing grade in this class. You have 2 tries to do so. I don't think I've ever had a student who was passing the class at this point and was unable by their second try to get at least 21 out of 28 correct. Most people get it right on their first try. So you got to practice though. So keep practicing, do good math, stay in touch. I'll catch you in the near future.